In this video, we're talking about the different types of strength, then what it means for a material to be ductile or malleable, and how they're similar and different, then hardness, and finally conductivity, how well a material conducts either electricity or heat. Okay, so question, which of these is not a type of material strength? A, tensile strength. B, compressive strength. C, shear strength. Or D, flex strength. My correct answer is D. Flex strength is not scientifically a type of strength, right? When we talk about the strength of materials, they're either tensile strength, compressive, or shear strength. So let's go into the details a bit, what they mean. Firstly, tensile strength. So if a material has high tensile strength, that means you can try to pull it apart, but it won't break. All right. And if you do pull it apart and it breaks, it has low tensile strength. So for example, let's say I gave you a 50p coin or a £1 coin, and I asked you to hold it in both your hands and then try and pull it apart. You know you couldn't do that. Why? Because the metal from which the coin is made has high tensile strength, right? It doesn't break easily when you're pulling it apart. If I gave you a piece of tissue paper or cotton wool and I asked you to do the same thing, you know you could very easily pull the cotton wool into 2 bits or the tissue paper into 2 bits. Why? Because those materials have low tensile strength. So that's the first thing to remember. Tensile is resistance to pulling or stretching. Okay, the opposite of that is compressive strength. So with tensile, you're pulling apart. With compressive strength, you're compressing, which means pushing together or pressing, right? So imagine you have a empty can of fizzy drink or a plastic bottle, an empty plastic bottle, and you're holding it between your hands. And I asked you to push, to compress, to crush. You could do it very easily. The bottle or the can would deform, right? So that's said to have low compressive strength. If I gave you something else like a rock or let's say even a golf ball or a cricket ball, and you tried to do the same thing, yet you wouldn't be able to. Why? Because the golf ball has a higher compressive strength. So tensile's pulling apart, compressive is pushing together, and then you've got something called shear strength. And shear strength is the ability to resist sliding forces. So what do I mean by sliding forces? So if you use your hands again, so the first one, you're pulling your hands apart, that's tensile. The second one is compressive strength, so you're pushing your hands together. Shear strength is when you're sliding one hand over the other. In the same way that scissors work or garden shears, that's a shear force, when you've got 2 forces moving in opposite directions, sliding over each other, right? So imagine, again, let's say you put a piece of paper in between the scissors and I asked you to cut it. The paper would cut easily because it has a low level of shear strength, right? If I put a piece of wood in there, it would be much harder to do. You might be able to do it depending on how thick the wood was or how strong your scissors were, but wood would definitely be more difficult than paper because wood has more shear strength. And then finally, if I gave you a bit of metal, like steel, and I said cut that with scissors or shears, you wouldn't be able to do it because the metal has a higher ability to resist those sliding forces, so it has a higher shear strength. Okay, let's do some examples. Should make it clearer. So examples of tensile strength. If you think of steel cables on, let's say, a suspension bridge, right, the forces at each end of the cable are pulling the cable apart, right? So the cable's under tension, but it doesn't break, it doesn't buckle. Why? Because the steel has high tensile strength. Another example would be your fishing line, right? So imagine you're holding your fishing rod and you cast your fishing line and a massive fish takes the bait and it starts pulling the fishing line on the other direction, right? So in that case, the fishing line will be under tension, right? But because it doesn't break, even though the fish is pulling one way and you're pulling the rod the other way, the fishing line has high tensile strength. Okay, and most ropes also have high tensile strength, whether it's for rock climbing or you're using it to, let's say, tow a car behind your car. You can imagine the weight or the forces are pulling the rope apart, but it doesn't break because it has high tensile strength. Compressive strength, so that's when you're pushing things together, you're compressing them. So concrete is a good example. Anything that we use in building, like bricks as well, they need to have high compressive strength, right? Because think about the ground is not moving down, is it? So it's making resistance on one side. And then the weight of the building, let's say the roof of the house, is pushing down on the other side. So if the bricks were squishy, right, or weak, they didn't have good compressive strength, it'd be no good, right? So that's bricks are a good example of compressive strength. And then you've got shear strength. So here it says cutting tools, but the cutting tool is not the actual shear strength. The cutting tool is providing the shear force. Anything that can't be cut by the tool, right? So probably like rock, metals, they have higher shear strength than softer materials like paper or even foods like bread, stuff like that. Anything that could be easily cut with scissors will have low shear strength. Okay, so there's the different types of strengths. Let's move on now. Question. Ductility describes a material's ability to A. Conduct heat, B. Stretch without breaking, C. Resist scratching, or D. Absorb water. The correct answer is B. Stretch without breaking. So what does it mean? If the material is ductile, it means when you pull it apart, right, it will stretch, right, but not break. So it's the ability to deform under tensile stress. So let's take, for example, let's take a metal or a wooden ruler, right? If you put it under stress, it might bend a little bit, but then it will break, okay? Whereas if you took a bit of copper, the more you put it under stress, it will just bend, right? So that it's able to deform without breaking. That's ductility. There you go, copper. That's why they use copper for wire. It's very easy to kind of stretch it and make them thin wires. Okay, then we have malleability, right? So be careful that they're kind of similar, but they're actually different, kind of the opposite. Malleable is the ability to deform under compressive stress. So soft metals like silver and gold, one of the reasons why they're so valuable, they're so popular for jewelry, is because you can beat them into shape, right? With a hammer or different tools, you can compress them and they'll change their shape, but they won't break, they won't snap, right? So ductile, again, think of ductile as pulling apart, as tensile stress. Remember we said tensile strength is pulling apart, the ability to withstand pulling apart. So ductile means it deforms but not breaks. It changes its shape when you pull it apart, when you stretch it. Malleable is the same. It will deform, but not when you pull it apart, is when you push it together or you compress it with a tool like a hammer or something. Okay, moving on. Question. On the Mohs hardness scale, which is hardest? A. Quartz, B. Copper, C. Steel, or D. Diamond? The correct answer is diamond. So diamond is the hardest material on Earth. What does it mean, Mohs scale? So Mohs scale, it ranks materials by their hardness on a scale from 1 to 10. So 10 is the hardest, 1 is the least hard. What does hardness actually mean though? It's the ability to, like, you can batter it, you can hit it, you can do what you want to it, but it won't scratch, right? So its hardness is the ability to resist scratches or dents. So here are just some examples. Copper's not very hard, right? If you whack it, it will dent, right? Steel is harder than copper, right? There's different types of steel. So you've got, if you mix steel alloys, like high carbon steel alloys, they become much more harder. So they're closer to 8, right? Whereas basic steel will be 4. And then you got diamond, which we said is the hardest. So that's a 10 on Mohs scale, right? So this Mohs scale, it might come up. So Mohs is just the name of it was the German geologist, I think, from the 19th century. So he was trying to compare the hardness of different minerals and rocks, so he came up with this scale. Okay, moving on. Question, which material is a poor thermal conductor? Copper, A, B, polyurethane, C, gold, or D, steel? And the correct answer is B, right? Metals in general, so copper, gold and steel, they're all metals. They tend to be good conductors, both thermal conductors, which is heat, and electric conductors. Okay, so first of all, what does it mean to conduct? Conduct means it allows to pass along, right? So let's say imagine you've got a long copper tube. If you heat one end of it, right, eventually that heat will move along the other end, right? Which is important when you come to do soldering. You've got to make sure you protect your hands so they don't get burnt. Let's say if you're holding a bit of copper, because once you put the blowtorch to the copper, the heat will transfer along the copper, right? Because copper is a good thermal conductor, right? Thermal conductivity, heat flow through a material. Now, the reason why it's a good thermal conductor is to do with electrons. You've got these electrons inside every material, but the more free electrons you have, those are what conduct both heat and electricity. Okay, so the opposite of a heat conductor is a heat insulator, right? This will not allow the heat to pass through it. So wood is a good heat insulator. Wool, right? That's why we wear wool clothing in winter, because it stops the heat from going through from your body outside. It's an insulator. And polyurethane is a kind of plastic. Also, it insulates heat, right? So that's the first kind of conductivity. Thermal, which is heat, means heat, right? The other type of conductivity is electrical conductivity, right? So same thing. Some things, if you put electric charge on them and you touch it, like an electric fence, right, you're going to get a shock. Why? Because the electricity is allowed to travel through, because the material is a good conductor. So again, most metals tend to be good conductors. In fact, gold is a superconductor. It's very good. So the opposite of that is electrical insulators. Again, wood doesn't conduct electricity, neither do ceramics or plastics. So why is that important? You're going to need to know that in your plumbing job for several reasons. Let's say you've got a water heater, right? And when you heat it up, it gets hot. But if you want to keep it hot as long as possible, to use the least amount of electricity, you're going to want to insulate that. So what will you insulate it with? Not with a heat conductor. It's going to have to be a heat insulator, a thermal insulator, right? So for example, something like wool would work for that. Okay, so that's electrical conductivity and thermal conductivity. So let's recap. So strength, you've got 3 types of strength. Tensile, which is pulling apart. It doesn't break when you pull it apart. If a material is said to have high compressive strength, that means you can try to crush it, but it won't break. And then shear strength is that you can subject it to sliding forces in opposite directions. Just think of the scissors. If you can put it in scissors and it doesn't break, it has high shear strength. Right. Then if a material is ductile, that means you can pull it apart and it does change its shape, but it doesn't break. Right. Malleable is the same thing. If you press it or hit it, compress it, again, it will change shape, but it won't break. Hardness just means scratch resistance. Again, you can drop it, you can hit it, do what you want to it, but it won't scratch if it's a harder material. And then you've got conductors and insulators. They're the opposite. A conductor allows heat to pass through it or electricity to pass through it. An insulator doesn't.